Let u equals xyz in R3 with such that x greater than 0, y greater than 0 and z greater than 0. Suppose we have the following functions: g equal x squared plus y squared plus z squared minus 1 and h equal x minus y minus z. And look to the set, show that the set of all x, y, z in U such that g equal h equals 0 is a manifold in R3, and what is its dimension. So this is a problem that asks you to prove that something is submersion. So if take f defined on U with values in R2, f equal g h being the function x squared plus y squared plus z squared minus 1 and x minus y minus z. Then the manifold g equal h equal 0 is actually the same as f minus 1 of 0. So you rephrase the question as a question about the pre-image of 0. So this will be manifold in case 0 is a regular value. So in case the function is a summation for any x such that f of x equals 0. So first of all, notice that the dimension of U is equal with dimension of R3, it's equal with 3, because U it's an open set in R3, and an open in a manifold is itself a manifold. Now take a point x in U such that xyz in U such that f of xyz equals 0. Then we need to prove that the derivative is a summation. So consider the Jacobian, which is given by the two gradients and has this form 2x1, 2y minus 1 and 2z minus 1. Now the derivative is surjective if the Jacobian has maximal rank. In our case, maximal rank means a rank of a 2 by 2 matrix. Now suppose that this is not true. Suppose that the rank of Jacobian is actually strictly less than 2. Then all the minors 2 by 2 have to be 0. So we have all the determinants of 2 by 2 matrices of this matrix to be 0. And this implies that x equal minus y minus z. But x and y and z are positive and strictly positive. So this means it cannot be x cannot be minus y because it will be negative. So this means that we obtain a contradiction. So f minus 1 of 0 it's a manifold because 0 is a regular value. Now the dimension of the manifold, it's always the dimension of the domain minus the dimension of codomain in the case of a regular value. So dimension of U is 3 minus dimension of R2 is 2. So in the end, dimension of f minus 1 of 0 equals 1.